The science behind hurricanes. Hurricanes, also known as typhoons or cyclones depending on their location, are powerful tropical storms characterized by strong winds, heavy rainfall, and potential storm surges. These storms form over warm ocean waters near the equator and derive their energy from the heat released when moist air rises and condenses. Here's a breakdown of the science behind hurricanes. Formation. Hurricanes originate from pre-existing tropical disturbances, often developing as low-pressure systems over warm ocean waters, typically above 26.5 degrees Celsius or 80 degrees Fahrenheit. Warm, moist air near the ocean surface rises upward, creating an area of low pressure below. As this warm air rises and cools, water vapor condenses into clouds and releases latent heat, further fueling the storm's development. Structure. A mature hurricane typically consists of a central area of low pressure called the eye, surrounded by a rotating band of thunderstorms known as the eye wall. The eye is relatively calm with light winds and clear skies, while the eye wall contains the strongest winds and heaviest rainfall. Outer rain bands extend outward from the eye wall and can also bring heavy precipitation and gusty winds. Energy source. The primary energy source for hurricanes is the release of latent heat as water vapor condenses into clouds and rain within the storm. This process, known as latent heat flux, fuels the convective activity and intensification of the hurricane. Coriolis effect. Hurricanes rotate due to the Coriolis effect, which causes moving air masses to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This rotation initiates the formation of a cyclonic circulation pattern around the storm center. Conditions for intensification. Several factors contribute to hurricane intensification, including warm ocean waters, minimal vertical wind shear, changes in wind speed and direction with altitude, and high humidity in the atmosphere. These conditions allow hurricanes to strengthen into powerful storms with sustained winds exceeding 74 miles per hour, 119 kilometers per hour. Tracking and prediction. Meteorologists use satellites, radar, and computer models to track hurricanes and predict their path and intensity. Forecasting involves monitoring atmospheric conditions, sea surface temperatures, and other variables that influence hurricane development and movement. Impact. Hurricanes can cause widespread devastation through high winds, torrential rainfall leading to flooding, storm surges, abnormal rises in seawater level, and landslides. Coastal regions are particularly vulnerable to the destructive impacts of hurricanes, necessitating preparedness and evacuation measures. Climate change. There is ongoing research into the potential impact of climate change on hurricanes. Warmer ocean temperatures may lead to more intense hurricanes, although other factors such as wind shear could also play a role in influencing storm behavior. Understanding the science behind hurricanes helps communities prepare for and mitigate the impacts of these powerful natural phenomena. Advances in meteorology and climate science continue to improve our ability to predict and respond to hurricanes, reducing risks to life and property in vulnerable regions.